Welcome, ladies and gentlemen, to another edition of Binary Life, a YouTube channel that teaches new developers how to code by solving algorithms and showing you the walkthrough process so that you can see how it works. Today, we're going to solve the Coprime Validator. What is the Coprime Validator? Write a program to determine if two given numbers are coprime. A pair of numbers are coprime if their greatest shared factor is 1. We can see here this is 20 and 27. These are the factors of 20 and these are the factors of 27. The shared number, the number common to both of them is 1, and this is the highest common number, so they are coprime. What about 20, 12 and 39? They are not coprimes because we can see that the greatest shared number is 3, which is not 1. Alright, so how can we approach this? The first thing will be in order to do this, there are 2 steps. We will need to get the factors of a number. And after we've gotten the factors of 2 numbers, we can now run through the 2 numbers and compare. So first, I'm going to write a function that get factors. Right, so I'm going to put this on full screen so that you can follow through. Let's put this in comments so that we can have what we're looking for. Right. Okay, in my function here, I'm going to create an array, an empty array that's going to have the factors of x. Let's just call it x factors. For now, it's going to be empty. I'm going to do the same thing for y. It's going to contain the factors of y. For now, it's empty. And in the beginning, I'm going to create a function that gives the factors to get the factors of a particular number. And how do we go about it? If you look at 20 here, it goes from 1 to 10. That's from 1 to the middle, and then we have the 20 itself. So basically, let's create an empty array here called factors. So I have a variable that starts at 1 here, starts at 1 and ends at, and including the number itself, and ends at the half of the number. This is 20. Factors of 20 is numbers from 1 to half of 20 that 20 can divide without a remainder. And then that's it. So I loop from 1 to the middle. So if our number divided by our looping number gives a 0 remainder, then it means it's a factor. So I'm going to push it inside the factors array. I'm going to push I. At the end of the day, I'm going to return all what is inside factors, the structure of the array, all what is inside here, and the number itself. Like for this case, every factor that was between 1 and 10 and the 20 itself. That's it. So this get the factors. So how do I get the factors of x? I just need to call the function above like this and give it x, and the same thing for y. Something like that. That's our first step, and now let's test it to see how it works. Just make sure that the numbers have the factors. So what I can do is console log the x factors. I'm going to console log x and its factors, and I'll do the same for y. Let's test. This is 20, and we have 1, 2, 4, 5, 10, and 20. That's good. And 27, 1, 3, 9, 27. So this works. All right. The next phase will be to compare these two arrays and count the number of common numbers. We're expecting just one of them. Like if we come back to the exercise, here they share two common factors. There is 1, 3, and there is 1, 3. Here they share just one, and that is what we expect. We expect just one common factor between them. So we're going to write another function that runs through these two arrays and counts the number of common numbers. All right, let's get to it. So this was the first one to get the factors. I'm going to write another one function to get the shared numbers, to get, how can I call it, common numbers given two arrays. So if we're given two arrays like this, the x factors and the y factors, how do we compare to see the number of shared numbers they have? First of all, I'm going to initialize my counter here to be equal to 0. Since it's going to be incremental, it shouldn't be a constant, should be let. So I'm going to loop through one of the arrays, the x, and then I'm going to check if every number that belongs in the y. So I use the for each loop of our x. So for every number in the x factors, I'm going to check if the number is included in the y array. Like for every x factor number, is it included or does it exist in the y factors array? If that's the case, something like this, as an if y factors include the x, then I'm going to increment our count. I can put like this. At the end of the day, let's return count. So it takes one array and check how many numbers there are inside here and returns the number of common numbers that exist between both arrays. These are arrays here, and we're going to apply that to these two here. So I'm going to create another amount of common numbers, or let's just say total common numbers. It's equal to, I'm going to call the function above and pass in x factors and y factors. Now, if this total common numbers, common with an O, if it's equal to 1, then they are coprimes. So I can just return a Boolean expression. I'll return if this total common numbers is equal to 1. So this returns true or false automatically. All right, I'm going to snap out of this and we test the code. Before testing the code, initially, this is the main function. We have this line that gets the factors of x, this line that gets the factors of y, and this line that gets the number of common numbers between the two factors. And then we return a Boolean expression to check if the total common numbers is equal to 1 or not. I can remove this comment section of console.log, and this is supposed to work without problem. These are utility functions here, the two above. The first one is to get the factors of a number, and the second one is to compare two arrays and count the number of common numbers between them. So I'm going to quit the full screen mode so that we can test the code. Right. Let's run the code. It passes the test. Let's attempt. And we are good to go. Now, what do we have in common with other algorithms? You see, I had to break it down in very small steps. Let's check this one. This one checks, it gets the minimum of both numbers. And then it gets the factors of the minimum number, the smaller number. And it checks if that factor is equally a factor of the bigger number. Oh, no, this is even wiser. Generally, every number will have 1 at its factor. That's why he starts at 2. He doesn't check 1. He starts at 2. And he goes just with the minimal number. Remember, he has filtered out the minimal number here. So he forgets the 1. 1 is common, it's a common factor of every number. So he forgets the 1. That's why he starts at 2 and checks the factors of the minimal number, the small number of both numbers that we're given here. And it checks if they are common factors, that if he finds another common factors are part of the one that he has already put aside. If he finds another common factor, then he returns false. It just automatically breaks out of the loop. No need to check further. This one is pretty much more efficient than what we wrote. So let's start again. I think this will be one of the most efficient algorithms for this. We're given both numbers. We take the smaller one, so that we're going to run through the loop in less number of times. And then we know that 1 is a common factor of every number. So let's just ignore 1. We start with 2. We get the factor of the smallest number. And we check if there is another factor other than the one that we already know. If we find any one, we just quit and return false. No need to continue the algorithm. But if this loop through the end and gets nothing, return true. That's it. That's as efficient as we can be. Probably no need to check another one, but that's really the most efficient algorithm here. I don't know about these. It's not that intuitive to read and understand. This is the same thing like we wrote, just using longer lines and other functions, JavaScript functions and filters. It's the same thing. This one gets the X factors, the Y factors, and the comparison to filter. It's the same thing. Exactly the same thing. Even though ours was longer, but this is exactly the same code. In terms of efficiency, this is the most efficient here. Right. I'm seeing multiple for loops here. This should look like what we wrote though. Getting the factors of X, getting the factors of Y, and looping through to verify probably. And checking if it's equal to 1. The same thing we wrote here. So I'm going to stop here for now. Every other code will actually look like something that we wrote here. which is efficient but slow, and this one which is practically the fastest. Right, so thanks for viewing and see you in another video for another algorithm.